Good morning, grade 11 students. In this session, we're going to continue what we have started before about the gene localization for grade 11, week 34. As before we start, how to verify that the affected recessive allele is to have or to search for two normal parents, they have an affected child. Whenever you reach this two normal parents having an affected child, so this will be the recessive allele for the disease. Or if it's dominant, you have to look for two affected parents, they have normal child. So by this case, you can prove that is dominant allele. Location of the gene itself, we have four different possibilities. Autosomal, it's found on the autosome from chromosome number 1 to chromosome number 22. Non-homologous part of Y, non-homologous part of X, and the homologous parts of X and Y. We move to verify autosomal. Mostly, I told you before that autosomal, you can leave it till the end. You can move to the XY, and you have to read the question. If they said in the question, for example, you have equal probability of male and female to be affected, so this can be autosomal, but mostly we don't do this. I don't give you this. Mostly, either I tell you, for example, the gene for the disease is located on chromosome number 7. Chromosome number 7, it's an autosome, so it's autosomal. By this way, you can know it's autosomal. Mostly, either I gave you in the text some hints in order to determine whether it's sex-linked or autosomal, or you have to determine this according to the pedigree to verify if the gene is located on the non-homologous part of Y. Non-homologous part of Y, you know that only males they have the Y chromosome. So to verify it, if it's located on the non-homologous part of Y, only the males should be affected, no females. Why? Because females they have XX. So if it's located on the non-homologous part of Y, so there is no chance. Or you can say every affected son should have an affected father. So every affected son should have an affected father. Why? Because the affected son will inherit YD from his father, which is also YD, so it should be affected. So if it's not the case, so it's not located on the non-homologous part of Y. Mostly, my students they choose this. They choose to talk about this. Only males they, will be affected, or since we have this female is affected, so it's not the case if you want to deny it. And third one, if it's located on the non-homologous part of X, every affected daughter should have an affected father. So كل بنت affected لازم يكون بي affected. إذا ما كان بي affected, so it's not the case. Hold almost, I'm talking about the allele disease is recessive. Also to verify if the gene is located on the non-homologous part of X and Y, the recessive daughter and the recessive son should have recessive father. Yani every daughter and every son that are affected should have an affected father. Here in this pedigree, we said that the allele of the disease is recessive with respect to the normal dominant allele. Why? Because the parents 1 and 2, they, 1 and 1 2, they are normal, but they gave birth to affected children, 2 1 and 2 2. So the allele of the disease is going to be masked. Here, from now on, I'm going to focus more on this keyword, masked in the parents. It's recessive with respect to the normal dominant allele. So these keywords or these sentences, you have to mention them because they are the key words here. Because if you don't mention them, you're going to lose some of your points. And if this disease is located on the non-homologous part of Y, none of the females should be affected. But in this pedigree, we have 2 2, which is affected, so it's not the case. If it's located on the non-homologous part of X, non-homologous part of X, always, I told you before, whenever you have a pedigree, I prefer to draw it in front of you. Draw it on a draft paper and then discuss it. Or if you have the question sheet or you have the exam sheet, you can use it as a draft using a pencil. You can try using this. So if you try it using the pencil, for example, if it's located on the non-homologous part of X, this individual is going to be, let's say, XD, for example. And this person is going to be XDYD. So if this person has XD, and XDYD, this individual is going to inherit XD from one of his parents. So here, XD from the father. And this YD from this is going to inherit it from the father. So the father should be XD, YD, but it's not the case. So here I deny it on the X and Y, on the both of them. So here then it's going to be autosomal. Pay attention in the question. Some notes you have to know about the symbols and about the justification for the dominant and recessive allele as well. So this question we solved them last time. So we said that the dominant and recessive, it was masked in the parents, I gave symbol and so on. Let's move now to the homework that I want to focus on during this session. In this session, the synthesis of hemoglobin is due to a gene localized on an autosomal chromosome. So they said it's on autosomal chromosome. So this disease is going to be autosomal. So the gene of the disease is located on autosome. It's autosomal. So they mentioned this in the text. They mentioned this in the text. So it's autosomal. The gene is present in the cell of an individual in two alleles. One allele is a paternal origin from the father, and the other allele is maternal origin from the mother. The two alleles are allele and capital that determines the synthesis of the normal hemoglobin and allele N small that determines the synthesis of abnormal hemoglobin. Here they use N capital for the normal hemoglobin and small for the abnormal hemoglobin. A person has normal hemoglobin if he has two alleles N capital and one allele N and one allele N capital means and one allele N small. So the one in order to have normal hemoglobin, it can be expressed either in homozygous or heterozygous. However, a person with abnormal hemoglobin has two allele N small and N small. So it should be homozygous and recessive. The pedigree in the adjacent document shows the appearance of the abnormal hemoglobin in the family. According to the pedigree, determine the gene localization of the hemoglobin gene, where it's located. They said, according to the text, is located on the autosomal chromosome. So mostly it's going to be autosomal. So you have to deny the X and also you have to deny the Y and you also have to deny the X and Y in order to reach the autosomal. So the first part, let's deny it on the non-homologous part of Y. Yeah, I need a volunteer. The non-homologous part of Y. Yes, non-homologous part of Y. One of you is going to be a volunteer. مين الانتحار اللي هيكون اليوم؟ To start with. Yes, Tala.
Um, um, is it like every
First of all, you have to
affected
deny it what?
son
Deny it on the non-homologous part of Y, right?
where? Yes.
Okay, so you have to say if the gene of the disease is located on the
Ah,
non-homologous
yes.
part of Y, and then you
If
continue. Yes, Tala.
if the gene of the disease is located on the non-homologous part of Y,
So
uh, then every affected son should have an affected father.
every affected son should have an
So
affected
يعني
father. Okay,
so I 2 1 يعني
2C.
C
C, yes. It's going
C
to have X,
uh
Y, and small, right? This is the genotype.
but A has
Normal. So it has X,
is
Y, and
normal,
capital,
so
so
it's
it's
not the
not the case.
case.
Okay, very good. So Tala solve it in one way. I need a volunteer to solve it in another easiest way, Tala. Let's see who's going to volunteer for this. Yes, Cynthia.
Okay. If the gene of the disease
Very good.
is located in the non-homologous part of Y,
Okay.
then none of the girls XX should be affected.
Okay,
But
so
2,
here,
3 is affected, so this is not the case.
so it's not the case. Very good. So here we can solve it in another way. Thank you, Cynthia. Thank you, Tala. So here we can solve it in another way. If the gene of the disease is located on the non-homologous part of Y, so none of the females should be affected. But here we have E is affected, so it's not the case. So here I deny it on the Y, on the non-homologous part of Y. Now I need one to deny it on the non-homologous part of X. Yeah, let's see. On the non-homologous part of X. I'm going to choose here. يا محمد حسان, good morning.
صباح أستاذ.
صباح الخير من تحت التخت طالع محمد حسان لايف اليوم. Yes, so you have to deny it on the non-homologous part of X يا محمد.
شو كانت الجملة المعلومة التي كمان
If the gene of the disease is located on the non-homologous part of X.
if the شو
The gene of the disease is located on the non-homologous part of X.
the gene of the هذا is located in the non-homologous part of X,
So
then بحكي عن G و H.
enter you have to choose. I don't know.
شو بحكي عن G و X.
Okay, احكينا عن you ask.
Then the alleles that represent G, G and H, then every affected daughter should have affected father.
لحظة هلا اجتك مسج I don't know بس انك انت عم تحكي عن جي و اتش عم تحكي لي every affected daughter وين الدوتر بالجي و اتش؟
اه شو نحن أستاذ؟ لا مش
نحن ها؟
مسج.
شو مسج فويس؟
لا كمان لا.
طيب if it's
every
located
affected boy. طيب مش girl، شو
every
رأيك؟
affected boy.
آه.
طيب first of all نحن هون عم نحكي على الاكس ما هيك؟
مم.
اذا عم نحكي على الاكس let's start with this. نحن قلنا الاليل of disease is recessive. هيدي male او female الاي؟ male or female؟
female.
female. so عندها XX right؟
صح.
صح. So this is عندها X sorry أخذنا نحن symbol and small. So X and small right؟ يعني هي عندها abnormal hemoglobin هو قال لي and small for the abnormal hemoglobin. تمام till now محمد؟
آه.
So this female or this girl will inherit XN from father A and will inherit XN from mother B, right?
آه.
So if it's the case هيدا الفاذر هيكون عنده XN Y هيكون عنده normal ولا abnormal hemoglobin؟
abnormal.
abnormal بس هو شو عنده؟ normal. So it's not the case. Here you deny it. Every affected daughter should have an affected father. هيدي هي كيف نعملها deny on the X. إذا ما كانت so it's not the case. So this daughter E is affected عندها abnormal hemoglobin. But her father, who will A, is normal. So it's not the case. So it's not located on the X, Muhammad. You have to review the notes, Muhammad. Otherwise, you can solve the exercise. Okay?
ماشي.
Okay, yeah. Let's move now. We deny it on the non-homologous part of X. We deny it on the non-homologous part of Y. Now I need a volunteer to deny it on both X and Y, on the homologous part of X and Y. يلا يا هاني. The homologous part of X and Y. I need you to deny this.
أستاذ
Deny it on the homologous part of X and Y. What do you have to look? If you have to dine on the homologous part of X and Y, you have to look for recessive daughter and recessive son, and they have a normal father. You have to look for this. عندي recessive daughter recessive son وعنده normal father.
Yes, we have C
Good.
and E.
C and D, very good. So C is how located on the X and Y, and the XY C. Will E and the XX, right?
Yes,
So is هون عندي yes C. What is the genotype? And it has abnormal hemoglobin. What is the genotype of C?
it's recessive.
So it will be what?
شو عاطين symbol نحن يا أستاذ؟
N small for the abnormal and N capital for the normal.
N.
N small, right?
Yes,
And this individual is affected also. So it be XN, XN,
XN.
right? So here, this individual is, C will inherit what from his father? Who will A? XN ولا YN?
will inherit YN.
YN, very good. And this daughter, هي E, will inherit one of these XN from the father. So the father هيكون عنده XN, YN, and is going to be affected.
Affected.
But from the pedigree, it seems to be normal. So it's not the case. So here the case is autosomal. So I'm going to repeat this step by step. Here in the question, thank you, honey. In there, the question, they helped you a lot. They helped you, they gave you the dominant and the recessive. They mentioned in a masked way, let's say. بطريقة أو بتاني قالوا لكم إنه مين الدومينant مين الريسيسيف. Why؟ قالوا لكم هون and a person has normal hemoglobin if it has two allele N or N capital and N small. So it's present in both homozygous or heterozygous. So it's dominant. So here they said that it's normal. So قالوا لي هو dominant. وقالوا لي يكون عنده abnormal but يكون عنده اثنين N small so it's recessive. Here first of all they helped you a lot in this part. In this part they helped you a lot in order to determine whether it's dominant or recessive. This is the first. Second, they gave you the symbols, N capital and N small. In the question or in the exam, I won't give you this. In the question or the exam, you have to give me the symbols. You have to determine whether the allele is dominant or recessive. And you have to determine the gene localization. And the first part, I'm going to give you, the first part is the first part in this question, but I won't give you these. انا ما بعطيك symbols وما بعطيك بقول لك dominant or recessive. You have to determine this using the pedigree. You have to use the pedigree in order to determine whether the allele of the disease is dominant or recessive, whether the allele of them is dominant or recessive, and you have to give the symbols. Here they helped you a lot. They gave you the symbols as well as they gave you the dominant and recessive alleles. Imagine that I don't have the symbols and I don't know which allele is dominant and which allele is recessive. Let's here determine this using the pedigree. Nada, can you determine whether the allele of the abnormal hemoglobin dominant or recessive according to the pedigree? Yes, Nada? Another, maybe she has a problem with the connection. So let's move to Mirna. Good morning, Mirna. Okay, great. Let's move to Lee. And then we can move to landscape, okay?
Determine it.
Determine whether the allele of the abnormal hemoglobin is dominant or recessive. I'm ignoring
Okay,
this, okay? أنا بعتبر إنه هو ما أعطاني هيدول وأنا بالامتحان I'm going
ماشي.
to do so. أنا ما بعطيكم. mostly حصعب لكم السؤال ما بعطيكم هيدول. Okay؟ يلا لي.
Since both parents A and B are normal, yet
Yes.
they gave birth to abnormal children C and E,
So
then they both carry the allele of the disease, but it's masked by the
very good.
dominant allele,
Stop,
which is
please,
normal.
Liam. Very good. Here, Liam mentioned that A and B they are normal, but they gave birth to two children, C and E, that have abnormal hemoglobin. So she mentioned that the allele of the abnormal hemoglobin was masked in the parents. So here it's very important. هيدا عليها a quarter. هيدا عليها إذا السؤال عليه 1 determine whether the allele is dominant or recessive. This one has a quarter. You mention if it's masked or not. If you didn't mention this, you will lose a quarter. So very good, Lane. Can you continue, please?
So the allele of the disease was masked by the dominant allele, which is normal,
Okay, so the allele of the disease is recessive
is
with respect to the
recessive with
normal
respect to
dominant
the
allele.
normal dominant allele.
Very good, very good. So here we determine the dominant and the recessive allele. And in this question, they use uncapital. Yes, Muhammad, you have a question before we continue?
أستاذ هتنزلها هيدي للسوليوشن.
Solution, we're going to talk about this at the end. Don't worry, we're going to talk about this. So here, Liam determined the dominant and the recessive allele. Second, they gave you symbols. Now, mostly I told my students, don't use the same letter, one capital, one small. And here in this question, they force you to use this, uncapital and unsmall. I use to give another symbols. Yeah, for example, the normal, give it uncapital. It's normal, un. But the affected, give it A small, D small, H small, but don't give it the same symbol. Because maybe you are going to write maybe انت على السرعة تكتب الكابيتال تكتبها small small تكتبها capital راح السؤال كله. So try as much as you can to avoid using both the same letter with the same for the same dominant and recessive. They use uncapital and unsmall for dominant and recessive. Avoid using this. Use uncapital for the normal and let's say D small for the disease or A small for the affected or H small abnormal hemoglobin, whatever. But don't use the same one. Okay? So here you have to use this. Here we determine the gene localization of the gene. We deny it on the X, we deny it on the Y, we deny it on the X and Y, and we reach its autosomal. And it should be autosomal. Already they mentioned this in the text. Sometimes I didn't mention this in the text. I didn't tell you, for example, that is autosomal, but I told you in another way. I said, for example, the synthesis of hemoglobin is due to a gene localized on chromosome number 10, let's say. And then I continue. But chromosome number 10, it is a sex chromosome? No, it's an autosomal. So the gene is an autosomal. So from here, you can determine that the gene is autosomal. So you can discuss it and you can determine it that is autosomal from here. And you have to read the text very well. Read the text carefully because mostly the answer will be in the text or the hints will be in the text. Okay? So here, autosomal chromosome, so it's located on autosome. While sometimes I'm going to tell you, for example, it's located on the X chromosome. If I told you on the X chromosome, so immediately it's going to be X-linked. It's going to be X-linked. What the meaning of X-linked? X-linked meaning that it's located on the X chromosome. So it's, or sometimes they said it's sex-linked. Sex-linked either on the X or on the Y or on the XY. They said it's sex-linked disease. So it's dedicated to the sex of the individual, whether a male or a female. So you have to know these terms. And also, sometimes if it's X-linked and I need to, for example, to do factorial analysis, if it's X-linked, sometimes it's going to be X-linked, and I'm going to do factorial analysis, you have to use the genotype. For example, if the genotype, let's say it's XDY, so you have to use the genotype like this. Gametes, 50% will be XD, and 50% will be Y, for example. We're going to discuss this later on. But first, I'm going to talk only about the case of autosomal. So here, part two, they said by referring to the text and according to the pedigree, specify the two alleles present in the cells of the father A, mother B, and daughter A. Father A and mother B, they are normal, but they gave birth to affected children, C, and E. So they carry the allele of the disease, but it was masked by the normal dominant allele. So they are N capital and small. And here N capital and small. And daughter E, it's affected. It has abnormal hemoglobin. And the allele of the abnormal hemoglobin, it's recessive. And it should be expressed in homozygous. So it should be and small and small. So this is the genotype and small and small. So here, pay attention to this please, and you have to be careful for this because this is important to justify. Because they said specify at the rhyme of Wi-Fi, so you have to justify. Here we finished the first two parts talking about the gene localization and specifying the two alleles. Meaning that specifying the two alleles, they said specify the genotype, the same concept. Specify the genotype of the individuals A, B, and E. For example, if I told you, Mahdi, individual C, what is the genotype for individual C? Yes, Mahdi. Individual C.
N كبيرة وN صغيرة.
And capital and small. Very good. Why and capital and small? Are we normal?
لا لأنها abnormal.
Okay, so abnormal. So and capital هي normal.
قصدي NN يا أستاذ.
And small.
آه
Okay. Also E and
فاهم.
small and small and H and small and small. So all of them they are and small since they are affected and the allele of disease is recessive. So maybe in the exam I'm going to tell you specify the genotypes of all the family members. ما بعمل السي لحالة والاي لحالة والاتش لحالة especially إذا كان autosomal. بعمل C with E and H, all of them together. So I can specify C and E and H, all of them together. So C, the genotype of C, E, and H is N small and small since they have abnormal hemoglobin and the allele is recessive with respect to the normal dominant allele. A and B, they are normal, but they gave birth to affected individuals or individuals with abnormal hemoglobin. So they carry the allele of the disease, but it was managed. So and capital and small and capital and small. F, it's normal, but they gave birth to affected individual. H, so it's obligatory and capital and small. And no way to be an N. If it's an N, all of the individuals, all of their children will be normal, but it's not the case. So here, no chance to be an N. What do you think about D? Yes, Renskake, what do you think about the genotype of individual D?
Individual E,
Yes,
because individual E is
D, D,
affected
D,
and
D,
E,
D.
sorry,
Ah,
because individual D is normal and
yes,
normal can be both expressed in the case of homozygous and heterozygous.
very good. So it can
So
be
it
what?
can carry both an N or N capital and small.
Very good. So شو كيف بتضيع بنصير نقول ان كابيتال ان سمول او ان سو كرمال هيك ما تختاروا اثنين letters نفس الشيء. So ان كابيتال ان كابيتال or ان كابيتال ان small. It has two possibilities. كيف بعرفها؟ بعرفها اذا اتجوز وجاب اولاد affected so اجباري بيكون ان كابيتال ان small or اذا عملنا له special technique. Here we finished part 1 and 2. So your homework, this is your homework by the way. This is your homework. Already we solved part 1 and part 2. So your job is to come to solve it by your own. Yani, your job is to solve parts 1 and 2 that we already solved them now. And you have to do the factorial analysis to verify the phenotypic and genotypic proportions of the couples E and F. Pay attention, E and F. So here I solved about 80% of the homework. So you have only to write them, parts 1, 2, and part 3, it's your job to do the factorial analysis. So this is your homework for today.